automation CI team at Linaro, where we kind of shepherd a few different projects and functions within the Linaro organization. So automation and CI, and that's just a very strange thing. So we've got the Lava team, the automation test framework platform. We've got the QA services team, where we provide both testing and validation analysis services and certification for some of the 96 boards projects. The builds and baselines teams, where we actually work with the individual teams to help them create software builds for the work that they're doing. What else am I missing? And then there's the reference platform, which is really kind of a focused software build, some focused quality engineering, some focused automation and CI around the concept of a reference platform. And then with the reference platform, the one other trick to this is it's really an end-to-end software solution, from the firmware, the kernel, the middleware applications, and the end-user applications for our segment groups. So we'll have Enterprise Edition reference platform, which is kind of end-to-end use cases around the enterprise software ecosystem. And the same for the consumer edition, for the home edition, and all these different editions of the reference platform. So we'll get into a lot of that. This conversation is meant to be a little bit of background on what the reference platform is, but as we discuss this and have this conversation, it'd be interesting to get your feedback as well. So that's me, Alan Bennett. Also, part of this conversation will be Miłosz. Is that pretty good? Anybody who doesn't know Miłosz, let me know. I've got to say the L because I just can't not say it. And then Fatih as well, builds and baselines engineering manager. So Miłosz runs the QA team. Fatih runs the builds and baselines team within Linaro. All right. So in Linaro, the reference platform again it's a program, but it gets a lot of its input from our different segment groups around Linaro. So you're going to see that the core team is rather small, but what we get from the other teams, it actually comprises of a pretty large software project. Of course, special thanks to everybody who's involved, both directly and indirectly, in making the reference platform. Each one of the groups, both from direction as well as some of the contributions, the improvements to the individual open source software projects. There are a lot of people that make the reference platforms possible, and we definitely appreciate all their work, including some assistance in the past and hopefully in the future from our landing teams who have additional support that they provide on the physical boards. And then at the core, so the center team there is really a group of the individuals who are responsible for getting that RPB constructed, validated, and tested for each one of the releases on the cadence that the different enterprise, or that the different editions have. I don't know if David Zinman's in here. So David is kind of the program manager for the project. He'll start the conversation and make sure that we're having the conversation about what makes up the enterprise reference platform. Amril helps facilitate the discussion with the teams and make sure that people are working on things. Fatih on the build side, Miłosz on the test and verification of it. Mark Brown, who does have a conflict right now, is our kernel maintainer for the reference platform kernel. We'll talk about it in a little bit. Then myself and another member, direct contributing member, would be Robert Wolf. There. From the 96 boards team, and really around the technical documentation side of the project. Okay. So what is the reference software goals? So you might have heard in George's keynote a lot of these, and we try to maintain a similar voice. So really we want to use the reference software as a chance to collaborate, work together, leverage the open source software, and then build a shared platform for the developers. And I think a key point to the reference software is we really want it to be a verification and an instance of an end-to-end reference product. So it should be everything from the kernel through the distribution, middleware, and then any end user applications. And it may be a customized set of those. So we might have one edition that is focused on only one use case, and so it's only one set of packages, and other editions that focus on similar end-to-end applications as well. A major goal that we have, do you have a question?
Yeah. So is the idea that you're testing software or you're testing hardware?
So the goal is that we're testing so the question is the idea that we're testing software or are we testing the hardware? So the goal is that we're able to test that end-to-end solution. Sometimes that means that we are testing just the software and there are open hardware issues, but the ideal goal is that we've actually got a solid platform from the hardware that we can actually test that end-to-end use case. And we're somewhere in the middle right now. So, but with the reference platform, we're really trying to build that software system on top of some stable hardware platform as well. So, yeah, I don't know if that answers the question. There's a lot of gray in between the beginning and the end of the goals here. So with that in mind, we really want to be able to provide a known level of quality for the reference platform. So we do have product level quality goals. So that's making sure that we've got good subsystem coverage, we've got good coverage of the features, good coverage of the systems that we put into a reference platform. And of course, the other thing we want to do is really focus on the upstream technologies. So we don't want to necessarily just focus on, to fork off of a lot of the upstream projects and build a single distribution off of a bunch of forks. We really want to try and keep the platform moving forward as close to tip in most of the projects as we can, which is also a challenge. So, any questions? So what does a reference platform look like? With this diagram, we can kind of see the overall block diagrams that would make up what we would consider the reference platform. So a security solution, your firmware, on top of your firmware is your kernel, the distribution, middleware, and then end user applications. And then what we really try to focus on is also taking that reference platform and a 96 boards product that is that kind of meets the goals of the program. So it's a near tip kernel that's got the support necessary in order to be that end-to-end reference. Just kind of any questions on? I think we'll be saying a lot of the similar things. So on the enterprise reference platform, it looks very similar as well. So you take the reference platform, you build your software stack up. You have 96 boards to verify, to be the verification hardware platforms for the release. And then kind of on the right here, you'll see the developer cloud, which is a kind of a production instance of the reference platform running on the cloud so that people can actually use that end-to-end implementation. Okay, a little more vocabulary around the reference platform. We also have what you'll hear from time to time is an RPB, which is a reference platform build. And so the build is, you've got a reference platform for the enterprise market, and then your RPB would be a specific collection of components that would then make up that build. So it might not necessarily be every application installed or that is installable. It'd be really a specific suite of applications and components that are put together for that build. Kind of I think of it almost like the silver thread that ties those components together so that you've got just what's necessary for that end-to-end use case. So your security, your firmware, your kernel, your user space applications make up that reference platform build. Of course, we also want to make this usable by the community. So we want to put with that reference platform build the necessary documentation to describe the platform build, how to reproduce it, how to make it really easy to use. So we focus, or our goal is to really focus on making sure that documentation is there, it's easy to use, and so that everybody can get the most value without too much of their own investigations. Each one of our reference platform builds should also come with a specification that defines the software that makes up that reference platform, so that we've got incoming requirements for building the reference platform. We've got the reference platform software itself, and then we've got QA and test reports that verify that reference platform and the components within it. I think this is key in order to make sure that people that use the reference platforms actually have something to start from when it comes to their quality and verification plan. So they can see what makes up the reference platform, they can see the test artifacts that were used to validate the most recent version of that reference platform, and then they can consume and use those within their own product development teams. Of course, the test reports that come out of that, and then again, you know, a key focus is really building these reference platform builds as close to tip as possible, to show everybody how to use the most recent software, software straight out of the communities, how to put it together, and then how to actually do that end-to-end use case using the upstream components. Of course, the RPB on different reference hardware may have some binary blobs in the firmware for key functionality, things like Wi-Fi, Bluetooth, Mali GPUs. But of course, ideally those would be minimal functionality, maybe not minimal functionality, but a minimal part of the system. So, you know, again, our goal with the 96 boards program is to have something that's open as possible so that people can see how to do this from the bottoms up. Another piece of vocabulary is the reference platform kernel, or the RPK. At the high level goal, the reference platform kernel, I think this statement probably sums what we would want the RPK to be, as far as a near mainline kernel that is used by the Linaro teams for the reference platform builds. So the key there is a near mainline kernel. And one of the big problems we have in Linaro is just the number of different maintainers of these kernels. So having enough maintainers to build your reference platform kernel and to track the changes when it's off tree is very difficult. But with our kernel working groups, if we have a kernel that's near mainline and we can get the board support into that kernel for the boards that the RPB is going to be validated on, it makes it so that we can leverage our core engineering team and somebody like Mark Brown to maintain that kernel, instead of having to have a team of kernel developers and maintainers maintain a kernel for multiple boards. That's kind of the goal around the reference platform kernel. And then just reference here, these are the different kernels that we have within Linaro. So the RPK being a base kernel plus in-flight board support, which is board support that is heading upstream to, so it's either being discussed on a mailing list or it's being discussed in the open through a patch series that Mark can then integrate into the RPK. But it's really key that support and that system is on its way upstream. So. And then the base kernel that he would then maintain is really, it's kind of demand based. So right now it's following the RC series. So this is primarily because the RPK is being derived from the leg kernel right now, which is tracking mainline with their features. And so we take the board support and we follow the latest RCs out of kernel.org. And then when we lock down a release candidate, we'll kind of freeze that kernel, do the test and verification for the Enterprise Edition throughout the release. But we'll continue to track with the LEG team and the Enterprise Rpv. We also have the LSK. I don't know if anybody has any questions about the LSK, but it tracks Greg Kroll-Hartman's long-term support kernel. And it also brings in member-requested ARM features in support for the 2 years. We don't necessarily build reference platform builds with the LSK because it is that historical kernel. We really want to keep the true RPK or the true RPVs built from the near mainline kernel. Of course, Linaro does have member kernels through our Linaro landing teams, where we'll have either a TIP kernel upstreaming tree that they'll focus on or LSK-based kernels. And then some of our segment groups do participate in maintaining their own kernels as they're doing development. Question or? Okay. Any questions around the RPK? It's So the question is, how long will the RPK kernel be maintained? So right now, it's a tracking kernel. So we will follow it through a release, and we'll do the verification and test of the RPK kernel at release, and then the RPK kernel will move to the next release so that we can leverage the maintenance from Mark Brown. So it's essentially right now based on the resources, more or less an unmaintained kernel over time. It's really that demonstration kernel. It's that how do you bring everything together and do the release and the build for a specific RPV release. And then what's most important is we take all of that and we move it into the next kernel as we move forward. And so we'll continue to bring those patches to support the next release from the last release, if that makes sense. Yes, I would say right now that it is more of the demonstration kernel. So if somebody wanted to take that kernel into production, it would have to be maintained. You'd have to have security patches come into it, all those different types of things as you were to lock down. If you do choose that as your strategy to lock down on a kernel, you would want to make sure that you are prepared to maintain that over time, because we don't have a maintenance strategy for the RPK for product development, if that makes sense.
RPK kernel. Is this RPK kernel for all different RP platform projects? There are so many different RP platforms. There are for IoT, for mobile, for LMG, something like that. So this kernel is for all these different RP projects?
So the question, I'll just repeat it just in case.
Yeah.
Make sure I understand it as well. Is there one RPK for all of the different reference platforms? So the answer is yes, sort of. So for most of the projects, we do try and track an RPK that is maintained by Mark Brown as that upstream tracking RPK. The differences to that statement are with LMG and an AOSP-based kernel, they track a different mainline for the LMG-based AOSP builds, which would be kind of the Linaro confectionery release. So in that one, they'll track I think it's the Google Common kernel. And so LMG provides a kernel base to use for the confectionery release, which is pretty much what we would use for the AOSP-based RPVs. Other projects, it kind of depends on feature support right now. So with the consumer edition boards, the RPK ideally would be the latest tracking RPK that Mark Brown is maintaining. A problem that we've had is the support of the features necessary for that RPB to be a feature-rich build. And so, for instance, the 1609 release is being built with the kernel that was released in 1606, just because we did not have the patches that were supported in 1606 follow forward for the consumer boards that we built the RPB off of. So the goal is, yes, it is one unified kernel. It is a tracking kernel that is close to tip so that we're not maintaining a fork. But there are some deltas to that strategy because of either resource loads, support from the necessary hardware vendors, etc.
If it's a common kernel for all different reference platform projects, if it will very tight for the merge windows for all these different projects, you know, if you maybe you need to handle a test for all different hardware so that and merge all parts from different platform. So this will maybe will, you know, you will let the project schedule become very tight so I want to know this if this will impact the RPK schedule and
Right.
progress. Okay.
So I think the question is kind of around, all right, so now everybody's relying on one kernel base.
Yeah.
And maybe this RPB's got a bug.
Yeah.
Will it, you know, really put at risk the rest of the releases for that release? It could. I don't know if we necessarily have all the rules in place to deal with that situation the most, you know, if it's that complex yet. But it is definitely something we need to come up with a strategy for, is to make sure that the release is not necessarily held hostage by any one issue on any one of the RPBs, but that we can actually, you know, separate them but keep them together. So it is a challenge that we probably need a better strategy for when we get to a point where we have so many boards releasing at this, or so many builds releasing at the same time, relying on a same unified kernel source. Yeah.
Okay. Thank you.
It's on GitHub. I think it's GitHub/Linaro/ just RPK. So sorry I didn't put that link in here. Oh yeah, the question was where is the public repository for the RPK? And so it's github.com/Linaro/RPK. Any other questions? I think the RPK is probably one of the key areas where we really want to make sure we have a dialogue with the community. Just because it's pretty important to this challenge, and a lot of it really builds the platform that we do our verification on as well. Is that supported feature-rich support within a Linux kernel, at least on the on a Linux-based RPBs. Apparently I should have brought my power. All right, so what does the matrix look like right now for RPBs? So each one of our additions, which is really just nomenclature, it's where we derive a lot of the strategy behind each one of these from, you know, a specific Linaro segment group or, you know, other goals of the program. So one being a consumer edition RPB, which is almost built around being the firmware software support for the consumer edition reference platform builds. So we currently are building 4 different user space variants. Most of them are pretty similar except for the graphics system. So, you know, the open embedded, we've got a console only, an Xorg based, and then a Wayland based system. We also have a Debian stretch. We've got the RPK, which is currently based off the 1606 release, which is the 4.4.11 based there. And then we tested on 2 boards, and there's a question around, you know, what is the QEMU strategy for doing builds and verifications on. I don't think we do any right now, but it's a potential. On so you kind of describe, so the question being, why do we have a Wayland build? I was wondering if you have a good reason behind the background. You can stand here.
So the Wayland-based image for OE is coming from requirement of AHJ, so we are using that. Some other people are still using Xorg and do some testing with Mali, so that's why we have 2 graphical-based build for OE, one based on Xorg and one for Wayland.
Yeah, so really the home group and some of their development use cases see that as a priority. So right now, the bootloader strategy is to really unify around UEFI. Again, that, you know, could change, but with the boards and the requirements we have coming in right now, it's really focused on UEFI at the bootloader level.
What about the 32-bit platforms? Have we just stopped caring about them, or are there builds for 32-bit?
So question around what's the strategy around 32-bit platforms? And I think just this release, we've started to look a little more.
Yeah, so 32-bit platforms are not lost. We have one coming actually from ST. So upcoming Rpv will add support for 32-bit builds. And I think one is coming also from Qualcomm. Yeah, so yeah, it's not done yet, but for upcoming release, we will have 32-bit support and builds and platform supported.
And the kernel, is that the same binary in both cases, or just the same source code?
It's the same source code.
So what's keeping us from having one binary for all of these?
For both 32 and 64?
No, for the consumer edition and enterprise edition.
So, yeah, the main issue is enablement. So for server platforms, it's kind of easy to have a unified kernel and have one binary. For ARM7 and 32-bit platform, it should be okay. But there's some use case where we can't have one single binary simply because some people are stuck on the user space because of Mali or some other binaries blob. So can you repeat the question, Ben?
So if we already have a kernel that runs on the high key and the DB410, what's special for that kernel that can't be used for the enterprise platform?
Enablement, again. So basically, enablement. So we can use the same kernel for CE and server platform, and we can boot. The problem is that for some use cases, we need more enablement. So what we have with the single kernel is just bare booting of a system. And for example, if you take Dragon Board 410C, for example, in mainline kernel, not all the features are enabled. And some might be, well, it will never happen, or it will take a long time. So that's why we will have a unified kernel. We have a unified kernel, but it doesn't bring the same enablement and the same feature enablement on the platforms.
I think that's really related as well to Justin's question around, having that unified kernel and requiring that for a release, puts everything, all the priorities, all the builds to make sure that that works on all those platforms. And so because of some of the enablements, we've had some divergence, I guess, from one single unified. The goal is absolutely one single unified. We just, with the reality between here and the goal, we haven't been able to get all the features necessary to have a feature-rich build in a unified kernel.
But the enterprise kernel will run with the basic feature set on all the other consumer platforms too, right?
Hopefully it's much more than a basic feature set. Yeah, so question/statement is really, if we continue to grow the program and we continue to focus on one single unified kernel, do we have enough resources to, in a timely manner, verify all the features that would come in? We probably don't right now. That's a big reason why the strategy is a near mainline kernel, because the ultimate unified kernel, I think, is mainline. So getting those features upstream so that they're supported, so that when we do build the unified kernel, we don't have to bring the entire technical debt of each individual with it. So right now, I think we're staffed sufficiently to cover the platforms, but as it grows, that would be a pretty big concern if a hard requirement was to use one single unified kernel. Getting all that testing done, those should probably go crazy. So on the Enterprise Edition Rpv, user space builds today focus around CentOS and Debian builds. We are, the 1606 release went with a 4.4.11, and the target for the 1612, the estimated 1612 release, estimated is on 4.8 with hopefully the 4.9 LTS releasing in that, near that time frame. We would do a 1612 release of the RPB and then likely a point release of an RPB when 4.9 releases, so that there's one tracking that next LTS as well. And then the current reference systems, the D02 and 3, also hoping to look at the D05 for the 1612. Qualcomm board, the Cavium Thunder X, and the AMD Overdrive. Any others coming? I don't think so. Not for 1612. Yeah. Let's see, so the home edition, so with the release of the Poplar board that you guys had a chance to see yesterday, we are looking at defining a build or two around the Poplar board for the home group. So those are in progress right now. We expect that, if not in the 1612, to be shortly after. We're also working with the home group on the cadence of those releases, how frequent, and the rest of the specification around the home, and then the same around the network edition as well. The network edition is looking at 4 separate releases. I have them in my notes, but I don't have them on display view, but there'll be more information about those coming out as well. Any other questions around what makes up the different RPVs? So there's a quick slide I added in. It's not in the download deck. It's just really to describe how the evolution of the reference platform builds would occur. So this is not a lot of specifics in here, but just to let people know that an Enterprise Edition could start and only be one specific build, and it's a very custom build, and it's not leveraged in any other builds beyond that. But for instance, the Enterprise Edition's reference platform is planned to be the base reference platform for our network, for a majority of the network builds. So you could see almost a make-from relationship where we have an Enterprise Edition reference platform, and from that we make the developer cloud image. And from that we make the network edition and other network editions. So we try and use this kind of an evolution model so that we don't have to rebuild from scratch every single one of them, but we can actually leverage both at the specification level as well as the test, verification, and documentation level, these different builds. Maybe any questions around it? So currently, for the two released RPVs, we've got two different cadence life cycles. One being the Enterprise Edition, where it's roughly a 6-month cadence, so you got about 26 working weeks, where the goal is to have the requirements captured in the first 4 weeks of the cycle. And we iterate both among the feature development teams as well as the platform teams and any upstream, feature review and inclusion. And the teams will iterate. After about 20 weeks, we freeze the features and we start working on the release candidates. So it's not necessarily a code freeze, but no new hardware boards are allowed after that date. No new, major software features would be wanted at that point, because we're really trying to harden the release in that remaining 4 to 6 weeks. And then the Consumer Edition is pretty similar, except for it's half as much time. And so the large features are ones that we would integrate and verify over multiple cycles, just because you really only have about 6 weeks from planning to release and the hardening cycle. So it's a pretty fast cadence. We'll be looking at that cadence to see if a quarterly cycle is necessary for the consumer platforms. But right now, that's kind of where we're starting from. Any questions on these? I know today we are not necessarily on this cycle. We are, I think we're, 8 weeks from 16.12 release, give or take. And so hopefully with the next one, we start those conversations a lot earlier so that we can really come up with our goals and our strategies with enough time to, allow the teams to do development and planning, especially for external partners as well. As anybody who's going to use this knows ahead of time what features are coming, what the major goals are.
The two, you mean you will give two release per year, is it right? For the Enterprise Edition, is it right? If that, I think maybe it's too little for the E version. Okay.
Oh, so more releases.
Maybe I think three per 3 months for our version is better, I think.
Right, okay.
Yeah.
I don't think Martin's in here, is he? Martin, director of the LEG. I think he might have been double booked. Yeah, that's great feedback. I think a concern that we've had is to make sure that we're not spending so many resources multiple times a year in the hardening phases. But really, these life cycles and strategies are built around each one of those segment groups. And so when it comes to the Enterprise Edition, I think we could support that if that was the direction that came out of LEG.
Enterprise Edition Rpv original cycle was 3 months. It was decided, within LEG group discussion with the members that 3-month cycle was pretty difficult to catch up for enterprise space. So I think it came to the conclusion that maybe we should start to push back the cycle to be twice a year, which is 6 months, and see how it goes. Obviously, we are always open mind to discuss the frequency ongoing.
Another thing around kind of the planning around these builds is, we'll go over it in a few slides, but it's establishing more of a structured community around these so that we're having the regular discussions with involved members, vendors, and users around that kind of on a bi-weekly cadence. So there's hopefully more of that communication challenges or channels that'll be opened to have these discussions and adjust, have the dialogue around adjusting the delivery cadence.
I just wanted to add that what we don't see on this slide is it's not only big bang release every 6 months. So we might have incremental updates of components during the life cycle. So for example, let's say we have an OpenStack update happening. We might have an update on OpenStack. We don't have to wait for a complete cycle to get the updated release.
Yeah, the components could definitely have different cycles. Any questions around life cycle? Are you taking notes, David? Did you capture that one? Yeah, okay. You look like you're taking notes. Okay, so, having product level quality goals, I think, is important. Asked Milos to really kind of summarize what those goals are. And so, you want to walk us through these?
I'll try. Okay, so as I was told, we're aiming for a product quality. So in order to get there, we need to define what the product actually is. So in order to get to do it, first we need to define the requirements for the product. Well, it's like, I don't want to stick to naming is like requirements, user stories, or whatever you call it. It's basically, we need to gather the description of what we want to do. And then for each reference build, there's probably the set of requirements will be different. So the consumer edition set of requirements will be different from the enterprise one. But among those, there need to be a decision or agreement which requirements are mandatory, so which made a core of the build. Without those requirements fulfilled, we won't release. And my idea is that the initial set of requirements should come from the 96 board specifications. There is a software part in the specs, and this makes a pretty good baseline for at least trying to define the requirements. Then I guess after the initial phase, we will go through the reviews and decide with stakeholders what the initial set is. So those should be composed of the feature requirements, performance requirements, then robustness. For the moment, there were a lot of complaints about stability of the builds that we produce. And the ultimate goal of this exercise is to provide the testing and validation coverage for all the requirements. At the moment, we don't test all the features, and we need to get there in order to ship the product type builds. And then after this happens, so this is still this is still the work to be done. After this happens, then some criteria for releasing needs to be defined. The proposals are here. So all the requirements or the mandatory requirements should be covered with tests. Then the optional requirements might be covered. I would recommend that, but it's not mandatory. Then for the testing cycle, the run rate of all the tests should be 100%, so all the tests should be run for a release. And for the mandatory requirements, for optional, it's not like they don't have to be all run, but if we have them, then why not? My proposal is to have the pass rate of 90%. It's, I would say, ambitious goal at the moment. But if you want to have a good quality, then this is a good target. And again, when completing the release candidates, the criteria for completing should be like no blocker defects to complete RC1, no critical defects to complete RC2, and well, of course we can dispute what is the bug severity based on the requirements and based on the goal of the release. I think what we should also aim to is that the performance metrics do not regress in the incremental releases, so we at least perform the same as we did last time, hopefully better. Now, whether we do time-based release or feature-based release is yet to be decided. I guess it depends on the group requirements. So at the moment we do time-based releases. So whatever features are there, we just release and either announce them as supported or not. So based on the testing criteria. So that's how the plan for ensuring the quality, like in a nutshell, looks like.
Improve your test case and attract more
Yeah,
test
so
case.
the idea is to have the 100% of coverage of requirements. We don't have the full set of requirements defined yet, so that's we don't have them covered, of course. And the set of tests we're using is open, so anyone can contribute to improve those. So there's no problem doing that. And my goal is to have the 100% coverage. So without that, it will be pretty hard to ensure that product level quality.
What sort of baseline would you establish for your performance goals?
The baseline for
performance goals.
Yeah. So that's still to be agreed. So I guess the baseline would be what we have now. If there are like no
because it's all going to be hardware dependent, right?
Sorry?
It's all going to be hardware dependent.
So the performance metrics should be per hardware platform. So we don't want to compare between platforms, but we want to ensure that the software that we run on each platform doesn't regress. So we compare apples to apples between each release and make sure that it doesn't regress.
Right. I mean, maybe since the vendors themselves do some of this testing, at least a subset of what we are doing, or actually they probably do a superset of what we are doing. So maybe you could get the initial numbers from them to serve as a baseline.
Maybe if they want to share.
Yeah.
Well, and that would be, I could see that kind of a sharing, really a Linaro to that specific member. So it wouldn't necessarily be to an open group, but we could definitely, because we want everybody to get, better performing products in the end. And so getting that information back to them, vice versa.
How do you make the link between the requirement and the test you are running? I mean, on the list.
I can't follow that.
Yeah, I can't hear the question.
How do you make the link between a requirement and a test or other thing?
Traceability. I think it's traceability between a requirement and a test result.
Yeah, so at the moment we don't have much of that. We're building a dashboard that will allow us to track between, like from requirements down to test results, hopefully. It's sort of, well, don't have a session on it, right? No, no.
Yeah, we're definitely recognize that, to take this to the product level, we need to bring in a lot of those practices. So have the traceability from the requirements that are agreed upon by the different groups, traceability through the feature, through the test and verification process used for that feature. And then, given that kind of a system, we can actually start tracking coverage percentage and improvements over time. So we're putting that in place.
Jan wanted the question.
Yeah, so more of a comment rather than question. So first comment on the performance. So by default, we are not going to compile, as Milos said quite rightly, we're not going to publish comparison between platforms and performance without specific agreement with both vendors.
I guess that the general comment is we won't be publishing any numbers, any raw numbers. We might publish something like this platform improved from last time by 10% or something like this, but
right.
Without raw numbers.
Yes, especially between SLC to SLC, it's not in our mandate to do so. Second comments regarding the test, I guess the traceability. So absolutely right. So we need to be able to establish from the requirement to the test cases, and that might evolve as well, and also that might vary from segment to segment group.
Yeah, I guess the requirements might vary from one build to the other, and I guess even for the platform, the set of requirements might be different because, for example, some platforms might not have some hardware enabled, like Dragonboard has GPS, Hikey doesn't.
Yep. Okay, so the next is really what's coming, kind of a discussion slide here. So we are working to establish a reference platform portal, which will kind of be the landing page for the project. Provide description, provide links to the specifications, the tests, the test coverage, etc. We are evaluating the new reference build use cases as they are coming in from the members. Getting our strategies in place, working with them on those specifications. Evaluating new hardware boards that are coming in. And, really, the closer you get to an upstream supported board, the easier it would be to bring into the project. And working with the 96 boards project, I think they talked about 2 different levels of 96 boards, both community and kind of reference hardware certifications. And then adding that's the different classes of the reference software. So the challenge we have right now is feature completeness with a near mainline kernel. We end up with something that is a little harder to do a full end-to-end verification validation on. The concept here is to have the ability to do some verification that's a little more complete for an end-to-end use case. Maybe it uses a kernel that's a little further from tip. Maybe it uses something that provides a little more feature support, but it's not quite a tip board, and that would be more of a community project versus really that reference platform project, which is trying to stay as close to the tip as possible, but maybe, but also to have the features necessary to really be an end-to-end use case board. So, yeah. I don't know if anything's written that specific, but I could see that as being logical. So the question around if you use the reference platform and then you make a change to it, and it makes a change that maybe violates one of the core principles of being an upstream. So maybe you take your kernel and it's a 318 based vendor kernel that works really well and provides all the features. can you still call that this is derived from a Linaro reference platform? Maybe. I don't know if we have that language really specified. I don't. Do you have any, Yang, as far as the plans on the 96 boards?
So the main difference between community, I mean, RP certified is really in terms of hardware, right? So the main difference between the first group in terms of community board and as to RP certified board is really down to the software. So that's really what is the difference between those two. For the community board, vendor provide software will be sufficient. For the RP certified hardware, you have to be able to meet the requirement we are setting for the board to become reference software worthy. For example, upstream requirement, open source bootloader, etc. So that's really the key difference.
Any other questions? We definitely want to keep the dialogue open. We will be establishing the portal and also some other communication channels as well. And so if you have questions you don't want to ask here, you hopefully have an open way to have that dialogue coming up. So stay tuned. We'll make sure that that information gets out. And you can always contact any of us, alan.bennett@linaro.org, and the other people if you have questions or concerns. So thanks for coming.